Again, another thing that we should be able to do with linear equations is write the equation of a line. And again, from a graph, there's one option of doing that. But from information, it's also very important. And this actually goes to a lot of things that we can do in math. The basics of statistics is just to take data and try to form, patterns out of it. So doing things like drawing a line or writing the equation of a line that passes through the point 2, 3, but would have a slope of -2. Basically, we're trying to find a pattern satisfying that information. Now, there's sort of two approaches to this. One approach would be we could find our slope, which we have, and we could just plug our point in. So again, if we use a y equals mx plus b idea, when y is 3, right, if y equals mx plus b, when y is 3, with a slope of -2, we know that x is 2, and we can just say plus b. We need to find that y-intercept. If we're going to write that form of the equation, we have to know that information. We need the slope, we need the intercept. So that becomes 3 equals -4 plus b, and if we add that 4, b equals 7. So one possible equation we could write, right, if they wanted a slope-intercept form equation, would be y equals -2 x plus 7. And again, that would be a perfectly good answer because they didn't specify what form we needed to use. Another great way to start, knowing a point and knowing the slope, let's use point-slope form. So y minus y1 is equal to the slope times x minus x1. And technically, we can just then plug in what we know. Y minus my y coordinate, which again would have been 3, is equal to the slope, which we know, times x minus 2. And really, if the form isn't specified, that is the equation for a point-slope equation. Now, how can we get two separate answers for the same thing? Well, what if we simplified real quick? What if we took that red equation and we said, okay, well, y minus 3 would be equal to, let's do a little distributive property, -2x. -2 times 2 would be 4. And if I add 3 to both sides, notice, don't we get y equals -2x plus 7. So really they are the same equation, they're just again in a different form. Either one of those approaches is a perfectly good approach to writing that form when they haven't specified what type of equation we want. Just write an equation of a line. Now you'll notice in the second problem here, we specified slope-intercept form. Slope-intercept form again being y equals mx plus b, which means we're going to need to know the slope and we're going to need to know the intercept. Noting that looking at our 2 points, I definitely don't have the y-intercept. Right? I don't know when x is 0. I know when x is 5, y will be 1, and I know when x is 3, y is -1. I don't know what y will be when x is 0. So we need to find that y-intercept. I'm also going to need to find the slope. So let's start with our slope formula. It's always a good place to begin. M equals, we can take our y1 minus y2, as long as on the bottom I say x1 minus x2. And again, they're interchangeable as long as my points stay kind of consistent. So m would be equal to, let's take that y1, so the y from the first coordinate, so 1 minus -1, so make it +1, over, again, I use the 1 first, I need to use the 5 first. 5 minus, again, x2 would have been 3, and basically m equals 2 over 2, or m equals 1. Well, once we've got our slope and we've got one of our points, again, we can use either approach up top, but we just need to end up in that y equals mx plus b form. So let's go ahead and take the first approach. I'm going to take out y in my equation. I'm going to plug in what it's equal to. If y were 1, with a slope of 1, we know that x is 5. We can find that b value. 1 equals 5 plus b. And if I subtract 5, b would equal -4. Therefore, y equals slope of 1 times x minus 4. And we could verify very quickly as well. When you plug in 5, 5 minus 4 is 1. And when you plug in 3 from our other point, 3 minus 4 would have been negative 1. And both points seem to work. I hope that again helps you remember how to write the equation of a line, whether in slope-intercept or point-slope form. If you have any questions, make sure you talk to your teacher. And otherwise, have a great day.